myself real fast. I'm a DPE at Google, Developer Relations Engineer, on the cloud and the apps team. So earlier, maybe a few of you saw me give an apps talk. That's what I used to do. Now I work almost 100% on some of these cloud technologies, including BigQuery, which is a sort of pre-release product that we're looking at. I'll show you a demo of it. It's not even available yet, but this is kind of a technology preview. I also work closely with the team that works on the prediction API, which is very cool. I think you saw it at the keynote. It's a machine learning in a box tool, and we'll try to build an app during the session that does some language prediction. If you're tweeting or Google Plusing, those are the hashtags I was told pertaining to this talk. But let's forget about that now and dive right into the talk. So what we're going to do first is an App Engine recap. Hopefully you saw Guy's awesome App Engine talk earlier today. We'll just do a Hello World app so I can show you what App Engine is for the few people in here who probably haven't heard of it. Then we'll look at Google Storage for developers, the prediction API, and BigQuery. We'll take a look at these three technologies that are also part of our cloud platform, and then hopefully we'll have time for summary and Q&A, and then we'll all go to Ignite, have some beers and party. All right, so this talk is really the story of Google. So let me explain. Google's what, I don't know, 13, 14 years old, something like that. And the mission was to organize, or still is, to organize the world's information. And that's a pretty bold mission. Over that decade plus, we've learned a few things about what to do with data. So we've had to develop tools internally for storing the entire web, an index of the entire web, analyzing log files for APIs and our web spiders. I mean, imagine you're spidering the web. You have a program that goes out and looks at every web page, and that generates log files. Imagine how many trillions of rows of log files that generates when you're indexing the entire web, which has, I don't know, 100 billion plus, a trillion pages. I don't even know what it is anymore. 8 exabytes of data, I think, is the entire web. So these tools came out of our infrastructure. We are offering them as products now because this is infrastructure as a service, right? So our storage infrastructure as a service, our machine learning technology as a service, and BigQuery is a data analysis tool as a service for you. As we build these products internally, we like to expose them through APIs for you developers to use. And we're very excited about that. We think that's going to be really great for new products in the future. Okay, let's do a 5-minute App Engine overview. Actually, more like 1 minute. Let's build the smallest possible App Engine app, which will probably be boring if you've seen guys talk, but let's just quickly do it. So the bare minimum you need for an App Engine app is something like this, an app.yaml file. Can you guys see the code? Is it big enough? Yeah? Okay. You need that, and this is basically a flat file that tells App Engine where to find the actual code that you're using, and it has a couple of other sort of configuration things, like we're using the Python runtime, and this is the name of our app. We're calling it GDD 2001 Cloud Hello World. And so what does this app do? Let's look at our Python script. It doesn't do much. It does almost nothing. So let's make it print something. So let's say, hello, Tel Aviv. Okay, so that's it. That's all the code I'm going to write. Now I have the App Engine SDK on my laptop. I'm going to run this program locally. Let's hope. So let's see where we are at here. Okay. So this code, this is where it's pointing out here. Let's see. Okay. And then let's do. All right. So it's pointing to the directory where that code lives in. It's going to find the app.yaml file, and it's going to run a program locally on my machine, I hope. All right. So look, it says it's running locally on that address. Let's go to my web browser. It's going to get more exciting, don't worry. So let's see what's going on with localhost. Nothing. What's happening? Oh, there it is. It's there. It was just hidden. Hello, Tel Aviv. Okay, so that is the bare minimum App Engine app. We're going to build a much more interesting app. But the point is, this is web application development in a box. Now, if we want to put this on the web, let's kill the local server. I've tested it successfully on my local server. Let's put it on the web. So let's do something like this. Instead of running the development app server, let's just do an app update. So I'm going to use this other script I have called app-config. This all comes from the App Engine SDK, and I'm going to update this. I'll show you that. So now it's sending it out to the cloud. Now I've already created a project in App Engine on the cloud that pertains to this application name, and it's getting pushed up there. It takes a few seconds. There's not much to this app, but it still takes a little bit of time. And let's go back here. Let me exit this mode so I can switch a little quicker. Yes, and I'll answer questions at the end because we don't have a lot of time, but that's right. So the SDK lets you, basically it's a copy of what is in the cloud. It's like a virtual machines for both Java and Python, and we also have a Go backend as well. Lets you run locally on your local machine, and then you can take the same code, push it up to the cloud, and it's running in a scalable environment. So let's quickly look at App Engine. So this is a bunch of demos that I've been writing for these presentations. So here's Hello World. The great thing about App Engine is it gives you a whole dashboard to go along with your application. So you can look at logs, instances. You can have different versions and switch back and forth. It's very cool. Now, this is getting kind of away from the stuff I wanted to talk about, but that's just an example of the environment we're coding in. So let's go back to this. Let me type in that. So let's go to, I forgot what I called my app, so I'll just go here. So hopefully this has been pushed. OK, it looks good. And my app is here somewhere, I hope. Oh, here it is. So now Hello Tel Aviv is live on the web, and everyone in the whole world can go see it, and it's running, and it's scalable. So if millions of people come to see this app, it'll probably be OK. And that's great. So that's basically what App Engine does. Now, we have these. Let me show you some other new technologies that you can integrate with App Engine, and I can show you sort of like how you can integrate these types of technologies into a web app that's scalable and can be deployed and for very quickly with very little code. So let's go back to our talk. OK, so I talked about this stuff. There's many other services, by the way. There's mail services, chat services, task queues, a whole bunch of stuff. If you catch Guy running around, he knows a lot more about this since he's actually an engineer on this project. We also have great development tools, an Eclipse plugin, and Google App Engine Launcher for Mac and Windows, I believe. I just use the command line for everything, but I heard if you like a GUI, we have that too. OK, so we built an app. Let's move into one of these new technologies that we have released from our infrastructure for you, Google Storage for Developers. So Google Cloud Storage for Developers, it's a way to store your data in the cloud. Huge objects, like 100 gigabyte objects you can store in the cloud. You have great control over your data, access control lists. You can make things public, private to a project. You can make things private to a user, private to a group. So this is great for stuff like, imagine you're a game developer and you have user-generated content, right? And you need to have permissions specifically for a particular user or a particular game environment. It's really great. The other thing we've done is we know a lot of people use Amazon S3, so we've made this product compatible, API level compatible with S3. So if you're a developer using that, it's easy for you to go back and forth between the two. It's great for, static content. If you're building like a picture, a photo, or video site, you're doing data storage for applications, backup systems. It's great. Build your own backup system. And also for computation, which we'll get in later. Putting big data sets in the cloud to do computation or prediction. Some stuff inside of Google that actually uses this product straight up. I mean, everything at Google uses this infrastructure. Gmail, I mean, everything uses a similar one, but this exposed API infrastructure is actually used by have you guys heard of the Data Liberation Front at Google? It's a group of people inside of Google that actually help you export your own data if you want out of our cloud. DoubleClick, Panoramio is like a photo application. They also use this directly. And then some early adopters are people like VMware and Guardian UK, and who else? Oh, the U.S. Navy. I mean, all kinds of early adopters have been using this with great success. So let's look at some of the tools for what this looks like. So we have two tools that are easy to use. I love command line stuff. I just like to hack on the terminal. So I'm going to use a command line tool called gsutil, and Google Storage Manager is a web UI, and I'll show you how that works. So let me go to. OK, so let's pick out a file. So I took Google's mission statement, which is right here. I'm just going to put this in the cloud using a gsutil and show you what that looks like. So I'm going to use gsutil to list what I have in the cloud. So when you use the Google Storage Manager, you basically create buckets in our cloud system, and then you can upload files much like a file directory. And the structure is much like your local file directory. So let's see what I have there already. Can you guys see that? Is that big enough? All right, so I have one bucket in there called Demo, Google Developer Day, Demo GDD. So I would like to first look at my Google Storage bucket to see what is actually in there. Nothing. There's nothing in that bucket. This is the web interface to my Google Storage location, so I'm just going to show you how easy it is. I'm going to copy. Copy command is just like doing anything on your local machine, and I'm going to copy it to this location. This is my Google Storage bucket in the cloud, and I already forgot what I called it. It's the demo GDD. copying file. Let's see if it's in there. Oops, it's not in there. Oh, there it is. There it is, right? So that's really all there is to it. It's much like copying to your local directory, but you can put it in the cloud. I didn't put any advanced permissions on this. I believe its default is to give only me access, but you can give, for example, a project level permission, or you can actually make it public. So if you're doing some kind of public project, you can just, if you're doing video, maybe you're making your own version of YouTube and you want to throw a bunch of video up there, you can make them public for everyone to see. What people are using it for things like game graphics, game video, game audio. That's a great way to use it. Create your own music site. There's a lot you can do with this. So let's quickly look. Oh, I showed you in action. So here's a summary. Yeah, excellent security, S3 compatible, so you can use libraries like JetSet and third-party libraries that are also Amazon compatible. We are working on App Engine integration. So this is very experimental. One advantage to using this over other systems like it is that it will be compatible with App Engine. So that App Engine app that I showed you will be able to quickly read and write files from your storage buckets, right? So you can do that programmatically. It's experimental right now. You can actually go to the Google cloud storage website and just actually start using it. I would recommend making production code on it quite yet, because it's still being worked out, and we're changing some of the function names. So sometimes things will break without just quickly overnight, but it's fine. It's fun to play with, and we're going to release it soon. So let me quickly show you. I'm supposed to show you how much everything costs. So let's just go to the web page itself, because I wasn't sure exactly what the costs were. So we want you guys to use it. So we actually have a free trial quota that gives you 5 gigs of storage. This is going to go on until sometime in 2012, I guess June 30th in 2012. You get 25 gigs of download data, and you have a limit to how many get and put requests. So you want to get and put data storage in there. And then the pricing is something like 13 cents for the first terabyte. I don't know what that is in shekels exactly. And there's also going to be a monthly usage fee. But basically, it's fairly cheap for the amount of data that you can store in there. And I encourage you to use it. I got a question today after my apps admin talk about storing data for an application, for like Android applications, and people were talking about maybe using spreadsheets or the data store. If you have a ton of data to use, this is really the way to go for your application. It's easy to use. It's compatible with other systems, and I think you should definitely take a look at it, especially if you're doing App Engine stuff. Okay, so let's go back. Okay, you guys all came here for the prediction API, I hope. This is probably one of the coolest things that we're doing at Google. People love it. Let's try to do some predicting. First of all, what is the prediction API? Okay, the prediction API is an API that exposes Google's internal machine learning to you to use in your own applications. There are 2 things it can do. Categorical classification, meaning taking data that you've already classified, feeding it new data, and the system will classify it to the best of its abilities. For example, spam and anti-spam, which I call ham. So we have spam and ham. Spam messages, you feed it maybe a collection of spam messages that are marked as spam. You feed it a collection of messages that you know are not spam. And the system uses that as a training model. So whenever you feed it a new message, it will compare that in its own way to that model and provide you with an answer. Is it spam or is it ham? Another thing we do, and we use this internally, right? Another thing we do is language classification. So if you ever use Chrome and you go to a website that's not in a language your browser is set to, it will try to guess what language that is. This site is in Spanish. Would you like to translate it? Those kind of things are what we do with the prediction API internally, and there's a lot of things you can do with it. The other thing we do is kind of a regression value. So in this case, you give it a model with many features. A good example is temperature. I don't know if you can actually accurately predict weather or temperature, but what you can do is feed it a list of historic values, say barometric pressure, wind speed, altitude, and then a temperature, and then ask for a new temperature based on those same features. In that case, it's not giving you one of the categories. It's coming up with a new number that it thinks the data that you fed it match. Right? So those are basically the 2 things to do. One thing to keep in mind is the prediction API, as fun and magical as it seems, can only give you information based on what it knows. So your training model, your data set that you train it on, is really the key to using it properly. The other thing to know is that we are internally always tweaking the system. So we use this system internally for all kinds of things, and it is kind of a black box even internally. And so when you feed this thing data, you need to remember that you can't change anything about the algorithms being used. We don't even internally do that much. You can simply feed it data and a model and get a result back. That's basically all you can do with it. But it's very powerful. So here's an example of what it can do. We're going to do this example in an App Engine app in just a minute. It finds relevant features in the strings that you're feeding it. So here's a sample data set. I've given it 4 sentences, 2 in English and 2 in Spanish. It looks at those sentences and picks out features that are unique to each data set, right? So that's what's unique to Spanish, and that's what's unique to English. Then, when you feed it some new questions, it uses the features that it's already been trained on to give you a prediction. So that's probably going to be English, and that's probably going to be Spanish, because it found similar features before. All right, so there's a 3-step process using it. One is upload your training data to Google Storage. So we just showed you how to use Google Storage Bucket. The system needs a data sample in Google Storage to get started. Then you build a model by running an API call that trains the system, and then you can start making new predictions based on that. So step 1, let's do this right now. Let's try to do this right now. So I am going to find some scripts. I took some scripts from our website. The Prediction API website has some really great bash scripts that you can do to quickly test some of these things, so you don't have to hack together a whole App Engine app or a whole Python script to get started. So let's see what I have in here. OK. So the first thing we're going to do is copy a training set. So I think I have a training set in here somewhere. Let me go up. Oh, here it is. So English or French.csv. So we're going to try to do a prediction model to see if we can pull out live English or French and have the machine tell us what it thinks it is. So let me just show you. OK, so can you guys see this? This is a CSV file of 2 news articles that I just randomly pulled from the web last night. So I just took the articles, I did a regular expression on periods, and I broke it up into sentences. It took me like 30 seconds. And I've classified them as English. So I took a New York Times article, and I classified that as English, and I took a Le Monde article, and I classified that as French. So this is just merely a CSV file that has both French and English sample sentences, random ones. This isn't a very big training model, so it's not going to be perfect, because if there's some features in here that I feed it later, it's going to mess up a little bit. All right, so I'm going to put this in my Google Storage bucket, so let me find my gsutil. I'm going to copy English or French.csv to gs gdd demo. Is that what I called it? I always forget what I called my bucket. Oh yeah, demo gdd. I'm like the absent-minded professor today. Okay, demo gdd, let's see if that works. No error there. Let's just make sure it's in there. Groovy. OK, there it is. So now we have it in there. So now we have to train this data. So I'm going to run a training script on the model name and the bucket. So training script on the model name. Let's call the model English or French, because that's easier. And the bucket, which is, let's just grab it out of here. Let's see. Oops. Sorry, I forgot where I am at. See, I told you I'd be fumbling through here when I forgot where all my scripts are. OK, that should hopefully work. All right, no, internal error. That always happens. Oh, hang on one second. I'm sorry about that. It's actually this. Magic. OK, so it says, thank you for that model. I'm training right now. So what we need to do now is take a look and see if that training has completed, right? So there's another script I have called check training. This is an asynchronous process, because if you have a huge model, it might take some time to train. This one's probably going to be done by the time I run this script. So I'm just going to run this sort of a similar command called check training and English or French. Can you see that? OK, good. Done. It's done. So it's trained. It's looked at the CSV file. It's created a model called English or French. Now I can try to feed it predictions. So let's see what happens. So I'm just going to run this script down here called predict. I'm going to give it the model name, predict against the model English or French, and I'm going to use some strings. So let's actually be safe and use one of the strings that we pulled out before. So let's just pick one like this. So this one should return English. This is kind of like a null hypothesis. Let's try it. English or French. What's going to happen? Oh, look. So, okay, so it worked, surprisingly. Can you see the scores there? This is not a lot of people ask, is this a statistical correlation, like a chi-square test? Not really. It's giving us its sort of certainty that this is English or French. So it's saying it has a 82% whatever score that's English and 0.17 that's French. So it succeeded. So you can put in all kinds of things. Let's try something slightly in French and see if it works. Let's just use a can French from here to just make sure it works, and then we'll try some random stuff. Let's see. I'll pick one without any characters because I might break it. So let's try that. So hopefully this will give it a score that's more French than English. And it does. It does. So that's pretty great. It works there. Okay, this is fun on the command line. Let's make an App Engine app that does this. I've written some canned code to make it go a little faster, but we're going to take the same model that we called English or French, and remind me if I start typing and I type the wrong thing to tell me it's English or French. And we're going to now hack a little App Engine app. So let's go to here and look at my canned code that I wrote last night. And let's see what I'm doing. Okay, so I'm going to throw a lot of stuff at you if you've not done App Engine app work. The prediction API requires authentication, authorization. And we prefer using OAuth 2. Hopefully you're familiar with that protocol. If not, it's not very complicated. App Engine has a great new thing called the simple OAuth decorator, which in your App Engine app, and a decorator is, if you know Java, it's sort of like an interface. It basically adds method functionality to an existing class or method in a class. And we're going to use the simple OAuth 2 decorator to kind of hide the complexity of the OAuth dance. So this is an App Engine app. All this code is on the App Engine website. Don't worry about it too much, but I'm going to show you the prediction parts. So I have an input form handler that's basically like a text field. I'm going to use that to predict some random text, and a prediction handler. And it's going to take that text. It's going to do something similar to what we did on the command line. I'm using the Google Python API client, which is great. Not to get too complicated, but it uses a discovery process to dynamically build methods. So you don't even really need to memorize API endpoints. You just call the discovery process. It finds the API endpoints, and then you start making calls. And the calls look kind of something like, let me see if I can find it, like this. So in this case, I'm using a service class which builds a bunch of endpoints on trained models, and then I'm going to predict the language based on this API. And then I'm going to have a default best guess, I don't know, and it's going to say I don't know if it can't find anything with a threshold greater than 0.6. I picked that arbitrarily. You can change that and tweak it to your needs. If it does find something above that, it breaks out of this loop and it says it's English or French. That's really all it does. There's a couple things we need to do first. One is that we have to get this working with OAuth 2, and we have to register this with Google in the Google API console. Have you guys seen any of this today? Is this all new? Or maybe Guy showed you some of this stuff? Okay, it's all kind of new. Okay, I'm going a little fast, but don't worry, it's not that hard. To use OAuth 2, you need two things from the Google API console, a client secret and a client ID. And then you also have to register the URL of the application, because this is a web app. Basically, you're telling Google that my web app is legit, and this is why. Here's my little tokens that show it's working. So that's what I'm going to do. I'm going to add that, and we're going to add our model name. So our model name is what? English or French, right? Or French. And we need to get a client ID and client secret from the Google API console. So let's pick the demo. Let's see here. I believe I have a dev days demo. Okay, so this is at code.google.com/apis.console, or you can just go to developers.google.com and there's a link to it. You'll find it. Let's go to our API access. So here are some client IDs and secrets I created. Let's go here. let's see. So this application's running is going to first run locally on my machine. Remember that URL, localhost, and then that port? So I need to say anything coming from that port making calls to this API should be fine. So I'm going to put that in, or put this client secret in to my app. Great. And I need a client secret as well. That was my client ID. All right. Great. So that's it. Let's see if this thing works. So again, I'm going to run the dev app server. Oops, let me go back to where it actually lives. Okay, so it lives in the prediction demo. So I'm going to run dev app server again, and I'm going to run this on my prediction demo code, and let's see what happens. Something always breaks when I do this. Oh, it looks like it's working. That's new. Haha, okay, so this is running. It's my text field. Let's see what happens when I put something in. So let's try it again with some canned English to make sure it's working. Okay, are you ready? Let's see if this might even crash. Let's try it. English. Okay, that's great. That's very exciting. And that's the JSON response. So you remember the JSON response on the command line? It's English. Let's try it with some canned French, and then we'll try it on Le Monde and see if we can actually get this to work on real stuff. So let me do something like this. Here, let me pick something like that. So this, oops, this should be French, or it will die because I didn't encode the Unicode accents properly. Let's see what happens. Okay, great, that's French. Let's forget about this canned stuff. Let's go to Le Monde and see if we can make it work on, whoops, Le Monde. Okay, let's pick this. Ooh, I'm so excited. Random. Random French? French! French, barely French. Thank you. I was a little worried about that. Let's make sure that wasn't a fluke and go to the New York Times and pull out something just random. How about, I don't know, this thing? Okay, let's try it. It's English, it works, sort of. Okay, so luckily this worked. Now, I only used 26 lines of trading data. So the features in here are based on those 26 lines, right? So it's likely that this won't work a lot. It'll throw out a I don't know, because that's not much data. You know, you really need more. So let's go back to our presentation, and I'll show you some best practices. Everybody always asks the same questions when we show this off. They ask, like, well, how much data do I need? Because it's really about the training model. Like, how much data do I need? So I wrote some rules of thumb. Okay, we skipped ahead of there. So for categorical predictions, like the one I showed you, 12. So I have 12 for English and something like 12 for French. So you need to try to have hundreds per category, right? So if you have, if you're doing 3 languages, you should have like 200 or 300 per language. That would be great. That's probably enough features to do a pretty good language comparison, right? If you're doing numerical stuff, so you're trying to like predict the weather, predict the stock market, doing something like that, you should try to have 10 times as many examples, like rows, as you do features. For example, if you're trying to predict the weather and you have a feature that says barometric pressure, wind speed, I don't know, rainfall, you know, a bunch of things, you should have 10 rows per thing, right? That'll give you an okay model. Better to have more. A smart scientist in grad school told me that big data beats a good algorithm every single time. So yeah, you can be smart and try to get around having just not enough data, but it's always better to have a lot of data. If you have all the data in the world, you don't have to worry about an algorithm, right? Because you have all the data. And we'll look at BigQuery, which shows you how you can use all the data. The more unique features, the better. So if you have 4 features, like if you're trying to predict the weather, that's okay. If you have 400, that's a little bit better. And another kind of rule of thumb with prediction is for text categorization, the size of the model should match the size of the query text, right? So if you're doing Twitter sentiment analysis, compare tweets to your training model should be tweets, and if you're comparing tweets. If you're doing Shakespeare and you're trying to predict something with a big block of Shakespeare's text, you should not be comparing it to tweets. That's not the right match. If you noticed with mine, I had those little snippets that were sentence size, and I was predicting using sentence size blocks. Okay? Okay, so that's prediction. We can answer questions at the end. I'll zip through BigQuery, which is not released yet. I'll give you a sneak peek. BigQuery is another externalization of Google infrastructure. We use it internally a lot, and we've written papers about it. We call it Dremel, and there's some public papers that we published about it, and it is very cool. It's a way to do ad hoc data analysis on massive data sets, and I'm talking about terabytes plus. It's all API-based, and I'll show you a sneak peek of it. Yeah, we use it inside. It uses a simple SQL-like, if you're familiar with SQL, a SQL-like query language, kind of a subset of SQL, and it's REST-based. We have JSON output and input, and you can actually integrate it into Google Apps Script. You guys just saw Ryan Boyd's talk about Google Apps Script. It's one of my favorite Google products. We're working on integrating them both. You can actually use it now, again, in sort of an experimental state, but we're rolling it out pretty soon. It's great for two things, like I said, speed, raw speed. It's probably one of the fastest ways to query massive data sets that you'll ever imagine, and scale. So you can just throw tons of data at it, and it tends to scale well. It tends to scale well. Like if you're a MySQL user and you're trying to do queries on, I don't know, billions of rows, trillions of rows, it's going to be slow. The relational databases are not going to handle this kind of thing. You need this type of model. So people are already using it for all kinds of things. There's analytics companies that are building things like Google Analytics, but with other products like game analytics, social metric analytics. You can build dashboards. If you were at Michael Fink's talk earlier, he was building dashboards with the Charts API. People are actually building products with that. It's a great way to do that. Business analysis, big companies are looking at it to do really weird business analysis, like comparing tweet sentiment analysis with product search results and all kinds of cool stuff. And a lot of things we haven't thought of yet, because this tool is kind of like democratizing big data analysis. It makes it really easy. So I don't have any code to show you, but let's look at a sneak peek of a web UI we built using the BigQuery backend, and I'll show you kind of what you can do with it. So let's go to our web client. You can see some recent queries that I was trying out. Let's do a compose. So I'm going to show you some data. I have some public data sets. For example, I have the revision history of Wikipedia. So every time an article is revised, there's a log entry. So we have taken that public revision history, and we've dumped it into BigQuery. So let's do some BigQuery Wikipedia campus. So let's look at how many revision records do we have in the whole system. Let's see. Oh, that was already in there, so let's run it. As you can see, this is taking 3 seconds, 4 seconds. So 4 seconds, and that's how many records are in this total. There are 313 million entries in this, and in 4 seconds we counted them all. So that's pretty incredibly fast. And honestly, we're in Tel Aviv. I don't know where the server is, but this is actually a little bit slow. So this is a remarkable speed for this kind of thing. So we have that many records in the system. Wikipedia remembers if it, the discussion pages, there are articles, and then there are discussion pages and talk pages. I'm counting all of those. So let's just look at the actual article revisions. In the Wikipedia database, it's called Wikipedia data, namespace equals 0. So let's run that count. Similar count. Should be less. So that's going 3.8 seconds. So that is an actual article revisions. There are 223 million, whatever, in that system. And I actually don't know I think this might be up until 2010, so there might be a lot more. This is just the data set that we have that we're using as testing. Okay, I don't know if you guys have ever seen one of our BigQuery demos before, but we always do this one because it's so hilarious. We're going to look at the top 15 articles that have been revised the most, right? So that could mean a lot of things. That can mean people are really interested in the subject, or that can mean that there's like a flame war for each one and people are revising them back and forth and there's edit wars. Let's just see what happens when we run this. Hopefully you can see this. So 2 seconds, 3 seconds, 4 seconds, going through 300 million records. Okay, 200 million records. Oh, there it is. So these are can you see that? So these are it only shows you 8 here, but these are the most edited Wikipedia pages. The very first one is George W. Bush's page. And the second page is the list of WWE wrestling employees. I didn't know that until I ran this query. So Michael Jackson also, United States. Jesus comes in 6th. Okay, so after I saw this, I had to run more query. I wanted to see, a lot of times when people revise things, they put a comment in the revision history that says, I reverted this due to vandalism or suspected vandalism or something like that. So I wanted to see, well, what are the queries that, that have that comment? So I wrote this query. So I'm selecting the title and the count from this sample set where the comment, when it was revised, contains the word vandalism. And I'm grouping by title and ordering by descending revert count, and I'm limiting this to 20. So let's see what happens. This isn't very scientific. 5 seconds, 6 seconds, 7 seconds, 8. Ooh, this is a tough one. 8 seconds. Oh, so these are these are maybe the most vandalized web pages. George W. Bush is there. That's what we suspected. Neopets? Led Zeppelin? Is that a controversial article? Adolf Hitler comes in 6th. Scientology and Star Wars is also very controversial. So these are kind of like, this is like a kind of hand wave. You look at the most controversial pages. I don't know what RuneScape is. Is that a game? Okay, is that a controversial game? I don't know. I'm not sure. Maybe the fans of the game are very into like, fighting. I'm not really sure. So that gives you a sense of like the power of a BigQuery. It is just blazingly fast, and you can do a lot with it. So if you have your own data sets, it's kind of like Prediction API. Stage it in Google Storage. I showed you how to do that. Upload it into the system, and you're ready to do queries. So that's a sneak peek. You'll see it sometime in the future. And I think that's really all I have. If you have any questions, let me put up the link to this presentation. Let me zip all the way to the end. Oh yeah, so we looked at sneak peek. So this presentation is actually an App Engine app that you can go to. That's the location. If you friend me, add me on Google+, whatever, I will post this link on my Google+. You can find my name around, or I can give you my card later. And that's all I have. I think the Ignite party is happening soon, so if you guys have any questions, ask me now, or let's go have fun at the party. Oh, yes. Yeah. Some of the APIs are integrated. Like some of them you just import, and some of them you actually have to, use a client library and literally paste it into your App Engine app. But yes. Yeah, usually for most services, it's OAuth is a good way to go. So you saw that step where I had to, oh, you know what? You didn't see it because I was already logged in and authorized. But you have to use OAuth to access. You remember that client secret and client login? That's the best way to generally do that, what you're asking. But yeah, you can. And they will use their own credentials. So they would log in with their own account and then have access to their own data that way. So that's basically the way to do it. We have lots of samples, actually. If you go to our App Engine code samples, we have samples for a lot of APIs, like how to use them. For example, there's a prediction API sample there that's much more interesting than the one I just showed you. And there's samples for a lot of our newer APIs as well. So yeah, take a look. Anything else before we go? Let's party.